Welcome to Study Loop.
All right. So in this problem, we have the setup. So we have a charged bar over here with length A and total charge is Q. And we have a point charge negative Q over here. So Q is positive and negative Q is negative. So for part A, we want to find out the electric field induced by the charged bar along the x-axis. So to do that, we need to utilize we just need to look at the very small part on the charge bar. Suppose just look at this part, okay? The length of this part is dy. So by using the Coulomb's law, we know that de is the electric field on the x-axis induced by this small part, equal 1/4 pi epsilon naught times dq over r squared, right? So dq is the charge for the small part, and r is the distance from the small part to this location. So we have this equal to 1/4 pi epsilon naught. dq in this case equal to lambda times dy. And r squared is x squared plus y squared. So x, this is x, and y is the position of this dy, okay? And lambda is the charge density of the charged bar, which is Q over A. So we obtain this equal to 1/4 pi epsilon naught Q over A times dy over x squared plus y squared. All right. So this is the electric field induced by the small part, and the direction of this electric field is pointing to this direction. I mean the electric field is pointing to this direction, E. This is a DE, okay? And then we can look at the x component and y component of this DE. So let's say the x component is DEX equal DE times, so remember that this is the charge bar, and this is the interested point, and this is the dy. So this is x, this is y. So dx will be equal to de times x over square root x squared plus y squared, right? And the dy equal to de times y over square root x squared plus y squared. So just plug the expression for de into these two expressions. We can obtain the expression for dx and dy. So dx is 1/4 pi epsilon naught times Q over A times times x dy over x squared plus y squared with power 3/2. Okay, and for this one, this equal 1/4 pi epsilon naught Q over A times y dy over x squared plus y squared with power 3/2. Okay, and then we can start doing integral to find out ex and ey. So ex is dex, which is so the integrating range is from 0 to a. So it's 1/4 pi epsilon naught q over a. Let's see, this is x dy divided by, sorry, not square root, it's just a parenthesis, x squared plus y squared with power 3/2. So you can use many ways to do this integral. I'll skip the mathematics here, and I'll just give you the result for this integral. So this equal to 1/4 pi epsilon naught q over a times So this result is, let me see, times a over x divided times 1 over square root x squared plus a squared. Okay. And EY is, yeah, and by the way, you can see that the EY is pointing down because this is the charge bar, and this is the interesting point. So EY is toward this direction. So EY is pointing, EY is pointing to this direction. So EY is pointing down. So we have an extra negative sign in front of this integral from 0 to a 1 over 4 pi epsilon naught q over a times y dy with the denominator is x squared plus y squared with power 3 over 2. And this integral gives you negative 1 over 4 pi epsilon naught times q over a times 1 over x minus 1 over square root x squared plus a squared. Okay. Yeah. So this is the expression for EY. And for part B, we want to find out the electric static force on the small q. So just utilize the Coulomb's law. So Fx equal Ex times negative q. Okay. So this equal, let me see, 1 over 4 pi epsilon naught q over x times 1 over square root x squared plus a squared. All right. Yeah. So this is Fx and sorry, negative q. And Fy is Ey times negative q. So this equal 1 over 4 pi epsilon naught q over a times, sorry, we have extra negative sign here, times negative q times 1 over x minus 1 over square root x squared plus a squared. All right. So this is the expression for Fx and Fy. And for part C, we want to find the result for the limit if x is much larger than a. So still remember that Fx is it's actually negative 1 over 4 pi epsilon naught times QQ over x and 1 over square root x squared plus a squared. So if x is much larger than a, we can just approximate saying that this equal to x. So this will become 1 over 4 pi epsilon naught q over x squared. Okay, this is approximately equal to. And for Fy, the expression is 1 over 4 pi epsilon naught times q over a and 1 over x minus 1 over square root x squared plus a squared. Okay, and under this condition, we have Taylor series x squared plus a. This has Taylor series equal 1 over x 1 minus half a over x squared and plus etc. So we just need to consider the zeros order and the first order. So I'll just plug the first two orders into this expression, and we can see that this equal to let me see. It actually equal 1 over 8 pi epsilon naught times q over a and times a over x squared. A over x squared. Let me see, is it right? And times extra 1 by x. Yeah, this is right. And just simplify it, and you can turn this equal 1 over 8 pi epsilon naught times q a divided by x cubed. Yeah, okay.